Hello. Good. How you doing? Hello.
How's it going?
Good. How you doing?
Not too bad. Waiting on this Cubs game tonight.
Do what now?
Waiting on the Cubs game tonight.
Waiting on the Cubs. It's a big one.
Yeah.
It's a big one. Yeah, they interviewed one of the stores across from Wrigley. He said, "What happens if they lose?" And I said, "Well, pulling bear material out."
Yep.
That's what's happening.
I think with the Rockies playing tonight, we should be.
It'll be a good game. It'll be a good game, I think. Internet giving you problems back here?
I think it was just on the wrong switch.
You got it working? What number?
But it wasn't here.
What number is that? Right now, yeah.
Make sure it's not turned off because we were doing a lot of work yesterday with the routers and stuff.
Yeah. Just make sure that yeah, just make sure. Disable, but the real one. There you go. Change that for settings on the left. And the Cisco deck should be disabled. Disable that. It says Cisco deck. Disable it. You want to disable it. Right click and disable it. Right click and enable the real world. Let's check the IP on that to make sure it's set right. Just go to that properties. No. Show you disconnected one? Should show you. Yeah, they have the Cisco. Still, you're also
frustrated. All about that, and then you forget frustrated. You begin to love what it is, but I know stuff. I know.
Yeah. All right, how's everybody doing tonight? We're going to go get started. We're going to be out of here by 5 tonight. I've got to the mall for our code, so we're going to be very short and sweet. But we're going to talk about steganography because we're going to be doing that on Thursday. If you've not heard of steganography, it's the art of hidden. And basically, it could be hidden writing, hidden. Stego means hidden in Greek. And so, stega, this part here, the Greek root is hidden. It could be hidden data, hidden back in the day before computers, hidden parchment, hidden whatever. During wartime, they used steganography to write with invisible ink and then put some type of lemon juice on it and it would reveal it. So anything that's hidden would be stega. And so we're going to talk this week, or on the lab Thursday anyway, we'll do a lab where we hide data in a bitmap file. And you can hide data up to the size of the bitmap file without seeing any degradation of the image. You can also password protect the image. So when you're looking at an image on the web, if you remember back in 9/11, there were some Al-Qaeda maps that were intercepted that did have some embedded maps in the images that use steganography. And so it's still used in warfare, also used in cyber terrorism for hiding data. And so we're going to look at steganography for sure, get a little bit into steganalysis, how to find images or MP3s or movies on your network that have Stega applied to it, meaning something's hidden in that file. And there are some analysis tools that we'll talk about and all these tools we'll be looking at this week are totally free to use to both create a Stega file and to intercept one and to extract a file from a Stega file. So we're going to go over, first of all, what is steganography? And again, from the Greek word steganosis, meaning covered, and the Greek word graphi, writing. So covered writing is where technically steganography means. Steganography is a process of hiding a secret message within an ordinary message and extracting it at its destination. Anyone else viewing the message will fail to know its contents, hidden or encrypted data. Greek history, warning of invasion by scrawling it on a wood underneath a wax tablet. To casual observers, the tablet appeared blank. Both Axis and Allied spies during World War II used measures of invisible ink, using milk, fruit juice, and even urine, which darken when heated and showing the text. And then invisible ink is also a form of steganography. So as a kid, maybe you had a kit that came in the mail or in a cereal box of invisible ink. Anybody remember those? And you're like, yes, I can write messages and nobody can intercept them. In fact, but the parents would find out or teacher would find out. So, oh well. You might have created codes at school where you could pass notes, and unless you had the decoding mechanism, even if somebody intercepted it, they weren't going to be able to translate it. So I think human nature is you're kind of interested in this technology and this type of tool. U.S. government is concerned about this issue, as you can imagine. Common uses include disguising corporate espionage, cyber terrorism, child pornography, human trafficking, drug sales, you name it. Steganography is used for evil, definitely. Rumored, though, during 9/11, Al-Qaeda had some images. Was a common technique they would use. They'd post on Facebook pages, websites, and a few of them were intercepted. They didn't capture all of them, but there was a few images they found out were. Steganography was used to hide maps and pictures because it looks just like a picture, basically. You'll see Thursday. Unless you knew the original file, you're not going to know any difference from the modified file because it looks just like an image. But if you extract it with the right program and put the right password in, you get a file out of it. And so that's what you'll find out Thursday. And so it's very good anti-forensics mechanism to mitigate effectiveness or forensic investigation. Again, child pornography is one of the examples. And my screen's frozen. So let's see if that works. There we go. Oh, and this slide's, by the way, in the task for this week, week 6 or week 7. Modern digital steganography is where data is encrypted, inserted, and hidden using a special algorithm. It gives a leftover bit of every byte, basically, and overwrites it with the data. It is simply appends data to the file or disperses it throughout. So, like in an image, like we'll do Thursday, every pixel in an image has a series of zeros and ones for each pixel. We'll pretend this is just one pixel color. And so what's going to happen is if you have a file that's, say, 5 megs, and this image file is 10 megs, it'll overwrite just one, the last digit, replace it with 1, and keep doing that throughout the image. It'll X out whatever's in there, replace with the data. And so as you can imagine, over time, when it's writing that file, you're not going to really notice a difference. It's only overwriting 1 bit in every byte with the most common algorithm used for steganography. Carefully crafted programs apply the encrypted data such that patterns appear normal. And again, this is one of the patterns we use Thursday, which is replacing 1 bit within a byte with the actual data throughout the file. So you don't really notice any difference. So here's an example. My hidden message, a carrier file could be an MP3, it could be a bitmap, could be a JPEG, PNG, MP4, you name it, any type of file. The larger the file, the more data you can hide in the file. Those types of, we'll discuss more types of steganography on Thursday. And then the carrier file hides a message to where the end user and the public is not going to know. Networking officials have issues finding these, and we'll talk about tonight before we leave steg analysis, some tools that can be used to detect files that have some anomalies to it. So here's some current carrier files in steganography: bitmap, JPEG, GIF, WAV, MP3, MP4 is another, and there's tons of other ones. Pretty much any file has an extension or even non-extension could be used to hide as a carrier file. Tools in steganography: steganosis, S-tools, steg hide, invisible secrets, JP hide, camouflage, hiderman, and hundreds of others. Most are open source, free, or some are commercial as well. Popular sites are on the slide here for steganography. Now, steg analysis is how you identify them. And it's not impossible to, it's difficult to, but not impossible. So identifying the existence of a message, not extracting the message, just identifying it is all it can do. So analysis of anything can just identify, not solve it or retract it or figure out what created it, if that makes sense. It just says you have basically a corrupt file with steg analysis applied to it, or steganography applied to it. So steg analysis essentially deals with the detection of hidden data. How is this meaningful? Because by identifying the existence of hidden message, we can identify tools possibly that were used to hide it. Just like every program, when it writes a file, usually puts some information, the header information of that file. Some of these steganography tools do that as well. Like if I was to give you an image, you bring it into Photoshop and save it as a PNG or JPEG, I could extract that file and look at the text portion of that image and see at the top of it, Photoshop version, whatever, version 7 or whatever at the top. So same with these type of tools. A lot of times they'll put data in the file when they write to it. If we identify the tool, perhaps we can extract the image. Again, this is a very low possibility you can extract it, but it is possible. Common hiding techniques appending to a file, like the one I wrote up on the board. Actually, the last one's the one we're doing on the board, which is the least significant bit. Hidden in the unusual header or unused header portion of a file near the beginning of the file. Or the most common is the algorithm mentioned on the overhead is used to disperse hidden message throughout the file, modifying the least significant bit per byte, like I've showed up here on the board, is nixing out one and replacing with the data you want to hide. Methods of detecting steganography: visual detection, where you can actually see a known, if you have images on your server, you can detect visual differences of those images, that they've changed, they've got pixelated, whatever. Very, one way to do it, very difficult to do, but one way. And who has the time to go through all the images to figure that out. Audio detection, crackles and MP3s and MPEGs, pops, stuff like that. Statistical detection, like changes in patterns of pixels or histogram analysis. You can determine possibly some detection, something's happened to that file. You might not know what, but something happened to it. Structural detection, like file properties. You notice every night a number of files on your folder in your server get updated or periodically, and they shouldn't. Maybe if it's static company files or corporate files, that could be a red flag. So size difference, date time difference, contents modification, checksum differences. And we'll look at all that Thursday when we do the lab. categories, anomaly, can do a histogram analysis, change in file properties, statistical attack, visually notice it, audibly notice it, or finally a signature, some type of pattern in the program that you can view in the file when you search it. The goal is accuracy, consistency, and to minimize false positive with steg analysis. So, detecting by viewing it, very difficult. Can you notice the difference between these two images? One of these two have steg analysis or steganography applied to it. Anybody notice it? No, probably not. Just by looking at it, very difficult. The one on the right's the one that actually has the image that has a file in it, but if I didn't put it in there, I wouldn't know that. Yes.
Your life would like have the clicker thing on it.
Do I know?
If there's a file inside of there, would it be clickable?
No.
No.
It's literally hidden within the image.
Oh.
Yeah. So when you download the image or view it, it's just a normal image.
Okay.
Yeah, it's not clickable until you use a program to extract it. Then you could, it's an executable. Then you could run it or whatever, or another file type. So kurtosis is basically the degree of flatness, or kind of like a histogram of a file. Very difficult, again, to determine what changed the file. It could be a number of things. Maybe somebody changed it on purpose, or an update, or you moved the file, or you opened the file and closed it. So a lot of different things could change a file's kurtosis. Histogram analysis can be used to possibly identify. Not real successful. Possible, not real successful though. Just by determining using a file histogram on an image, you might notice some changes from. Again, you'd have to have an original file to notice the change, and that's really the kicker. If you don't have a tool on your network that looks at backup files and native files that are currently on the live network, very hard to capture. But you could compare histograms if you had this snapshot of the life cycle of that file to determine if changes have been made. And then comparing properties like timestamp, like this example here, 2003 525. Notice 240 by 759 is the size. Now it's 235 by 750, and it was saved at it's 526. Checksums are different as well. That would be a red flag. Hexadecimal signatures could also be a red flag. And there's tools to test that as well. So if you have a copy, and that's a big if, I guess, to a lot of places. If you have a copy of the original file, the virgin file, if you compare it to the modified suspected file, there is a lot of tools that can be used to help you determine. Everything from Notepad to Hex Editor can look for inconsistencies in a header file. Reviewing multiple files might identify, but again, you need to know where to look for. You're going to look through every single file in your network? Probably not. And so a lot of places won't do a steg analysis until maybe it's too late after something's happened and they realize things have transpired that they were unaware of, and then maybe they bring some of these tools that we're talking about tonight. Most employees and most IT folks have no clue what steganography is. Zero. Never heard of it before. Been around for centuries, actually, but in the computer world, not real commonly talked about, but it is commonly used on the behind the black curtain, you could say, and they used for bad things and hiding things and stealing things and things of that nature. So some helpful programs that you could play around with. We'll play with some on Thursday, the one that's built into the app. WinHex is one that you converts ASCII to hexadecimal. You could look at the header file to see if there's any anomalies. Hiderman. This is a program used actually to hide files and to unhide files. You literally drop a file on the left side that you want to hide, and when you want to extract it, you click on the file, the box or the button on the right side, it asks you for a password, and it extracts the file. And so one of the programs we use, we won't be using Hiderman, but one like that on Thursday. So a case study by Hiderman. After hiding a message in Hiderman, we can review the file with our favorite hex tool. Viewing the header information beginning of the file, we see that it's a bitmap is indicated by this BM indicator, file signature. Okay. Then when we view the end of the file comparing the beginning file or the version file to the carrier file, note that the data appended to the file at the end. So it ends in 000 here at the top of the original one. Here's the bottom one, and highlighted in black underneath it is a new data that was added once Hiderman was used to hide data in a file. Now you'll notice it makes literally no sense over here what program was used, and if you look at the ASCII portion, but you notice something has changed. Hiderman did do some things to it, but again, that's knowing what file you used, exactly what the before and after file was, and again, that's going to be hard pressed to have for networking folks to have that information. It all goes on, so in addition, note the last three characters, CDN, at the end of it. Hiding different messages and different files with different passwords, we see that the same three characters are appended to every file that was used for Hiderman. So that's more than likely the signature found, and definitely is a signature found for Hiderman when that program's used. So a simple scan of a network for that signature could be raise some red flags and look at files that maybe have this applied to it. Steg Spy. This one's a signature identification program. Searches for Stego signatures, determines the program used to hide it. It's not 100% accurate. It identifies 13 different steganography programs, and there's hundreds of them out there. Identifies location of a hidden message. And so notice when it scanned a file, it noticed it was the Hiderman was detected when it scanned it. That's one example. And we will have links to all these on Thursday. One of these, the Steg Spy and all that. Well, it's spyhunter.com. Signature-based steg analysis also use identify programs, including Invisible Secrets, JP Hide, that's a popular one. Hiderman's a popular one. So why is it handy on steg analysis, or how is it handy? There's no original file to compare to. If you have no original file to compare to, you're pretty much, out of luck. You're not going to be able to test anything. Well, you could test something, but you'd have to know what the signatures you're testing for. Searching for the signature to determine presence. Signature reveals program possibly used to hide the message. Now steg analysis meets cryptanalysis, revealing hidden files. So cryptanalysis is taking the next step further, and basically cryptanalysis encrypts the file you're hiding in the source file. So it doesn't just hide the file, it encrypts it as well. And so cryptography means to encrypt the message. And so even if you were to get a file extracted, you'd have to decrypt it to view it, if that makes sense. And so, again, unless you have the original file that created it with the original password, and you'll see on Thursday there's like 8 different encryption types you can apply on some of these programs. So you'd have to hit the exact encryption type and the exact password that was used to extract the file, which would be near impossible to do. So knowing the steganography program used to hide the message can be extremely handy. Again, it's for investigation purposes or educational purposes. Identifying and cracking the algorithm can be quite daunting. It says, unfortunately, some of these programs use strong encryption higher than 128. I've seen them up to 1048 encryption, which is, take thousands of years to crack the password or an encryption both. So revealing or cracking a password, seeding, or what's called a secret key. Practically all steganography programs use a password to hide the message. Some of them that we'll use this semester, when we go to there's one of the labs we do where you can encrypt the entire hard drive, can take a source file, not just a password, but a source file that you need both to decrypt the file. So identifying the program used to hide the message in cryptography or cryptanalysis, identifying location of the password, location of the hidden message, and identifying the algorithm. That's the job of cryptanalysis. And like it says up here on this slide, basically it's a lot of guessing once you figure out the program is figuring out what the password might be. There is a few password guessing programs that have been created, like outguess.org for StakeBreak. LinuxForensics.com has some on a Knoppix CD called Penguin Sleuth that does forensics for files. And then good old-fashioned brute force, reverse engineering, and looking at the least significant bit, trying to figure out a password that way. Also, other common algorithms used to steganography is XOR, DES, 3DES, IDEA, and AES encryption. Another case study called Camouflage. Camouflage app used to encrypt, hide file in another file. This uses a multi-text viewer and finds highlighted here some anomalies with the file. And so the password is known to be test, which is that hexadecimal converted into ASCII. BDH tool can use XOR to reveal 2 keys or reveal a key. And then other anomalies within the XOR brought about the first 4 digits of the key are this. So again, this test was done with a file they already knew what the password was and was able to determine it, but they already knew what the password was to determine it and was searching for it and found it. So Camouflage said they restored another password using a different password. It revealed a hexadecimal value. They XOR'd it with a known key, which was that test key. The result was that 61616161, which is a password of 4 A's. We revealed the hidden password to hide the message and was able to extract the file. But again, it's a very simple password too, test. What if they use a more difficult password? Probably more difficult to find. So I want to forward fast to some apps that we'll be using on Thursday, or some tools that we'll talk about on Thursday. So here's some tools for detecting anomalies or steganography: LNS, LADS, NTFS, ADS check. And a lot of them are DOS prompted, as you can see. And you literally can scan entire networks, entire folders, entire data structures, or a unique file if you want to. So a lot of stuff to investigate. You'll find out more on Thursday. Your eyes will be open to the program we use, but a lot of other investigations can be done and research on other programs besides the one we use on Thursday. You can even write your own program that can do steganography, create your own algorithm. A password grinder may vary. Again, very difficult to do unless you know the original file and original cryptography used to encrypt that file. And statistical analysis has been performed, also capable of detecting steganography programs like histogram, least significant bit. But a lot of those have been done in closed study demos, really, if that makes sense. Stego Watch by Westone Technologies is a program that runs to look at networks, folders. They have training, investigators that will help in training people on steganography and the tools used to help network administrators. Steg Detect detects JSTEG, JP Hide, Invisible Secrets, Outguess, F5, and Appendex and Camouflage. The site was pulled because of Michigan law on that one. And then some more references here. So Thursday, let's go there real quick. You can look ahead if you want to on Thursday's lab before class. There's 2 files in here. One is the lab itself. One's a needed file, which is a zip file that includes the executable we're using to do the hide file in. And let's see here, I can show you real quick. It's this H8P21_EN zip is the one we're going to be using. That's a bitmap we'll be using. The file we'll be hiding in the bitmap is this text file. And then we'll at the end have you guys actually hide Notepad in that original bit file, and you'll be able to determine the original. You'll have the original bitmap with the modified with the text file, the original bitmap with the modified Notepad exe added to it, which is real close in size. You'll definitely be able to see the degradation of the image that way. So it's an interesting technology. It's something you should be aware of. We'll talk more about it Thursday as far as what you can do as a network administrator to find these on your network. So yeah, steg analysis, steganography, and you can read ahead if you want between now and Thursday. A lot of different. You can work in this field like totally full time, steganography and steg analysis. That could be your job, and there is need for it, by the way, both not just in governmental but commercial and local businesses that have a lot of copyrighted or patented data will store their information using steganography on purpose on servers just for an extra added layer of security. I know a company that uses steganography on their sales department. All their contact database and files are stored on a computer, but using steganography, it's actually embedded in images, and then they have the steganography program on a USB file or USB drive that has to be plugged in, has a seed file they have to grab, and then put in a correct password in order to decrypt that that contact database. And then once they close the contact database, it's deleted from the computer. And so there's a lot of cool ways it can be used to secure data for sure. One of the ones I created for a company here locally was, you guys have heard of Google Earth, right? Everybody's heard of that. Well, Google Earth has what's called a KMZ file that drives it's a data for Google Earth, where you can customize a KMZ file to put the custom pins on the map. And this company basically used it to determine locations of sites. And then when you highlighted the pin, it would give unique demographics of each one of the locations. Well, I created a program that used this technology and coupled with a couple other technologies, which was when they opened up the program, it did install it in the local drive. It's just one executable, and they could do their work. But then when they closed the program, it deleted every existence of that file on the computer. And they've been using it for like 5 years now. And I had to update it here last year for them. But there's a person in the business that updates that KMZ file all the time. And I just take a snapshot of that each day. And there's a program that runs that zips that file together, creates an executable. And in that program, I've developed that logic I just mentioned, which deletes all existence of the file once it closes down. There's like one folder it keeps on the computer, but that's it. All the files are actually deleted. And so, and that was a request that they wanted because they didn't want this KMZ file to get in the hands of other salespeople because, that's bread and butter for companies that contacts of your customers are bread and butter. So anyway, we'll talk more about that Thursday and some cool uses of it, some evil uses of it as well, but cool uses of it as well for security. So that is it. I got to go Cherryville Mall and have fun with some kids. And so I will see you Thursday, same time, same bat channel. All right. Good job.